Hello world, we are Hello World. In this video, we will introduce you about the deep learning. And this video contains four sections. The first one is introduction, which includes the introduction and the definition of deep learning. The second section is about the history of deep learning. In the third section, we will introduce you some typical architectures of deep learning. And in the final session, which the fourth session is about the application in real life of deep learning. So let's get started. It has evolved hand in hand with the digital era, which has brought about an explosion of data in all forms and from every region of the world. This data, known simply as big data, is drawn from sources like social media, internet search engines, e-commerce platforms, and online cinemas. This enormous amount of data is readily accessible and can be shared through fintech applications like cloud computing. However, the data, which normally is unstructured, is so vast that it could take decades for humans to comprehend it and extract relevant information. Companies realize the incredible potential that can result from unraveling this real information and are increasingly adapting to AI systems for automated support. One of the most common AI techniques used for processing big data is machine learning, a self-adaptive algorithm that gets increasingly better analysis and patterns with experience or with newly added data. Deep learning, a subset of machine learning, utilizes a hierarchical level of artificial neural networks to carry out the process of machine learning. The artificial neural networks are built like the human brain with neural nodes connected together like a web, while traditional programs build analysis with data in a linear way. The hierarchical function of deep learning system enables machines to process data with a nonlinear approach. So, what is deep learning? Let's move on to find out the definition of deep learning with Huang and
Okay, Yuan has introduced a general view about deep learning. My name is Huang An, and we will talk about the definition of deep learning in a nutshell. Deep learning is a class of machine learning algorithms that use multiple layers to progressively extract higher level features from the raw input. Look at the picture, for example. In image processing, lower layer may identify edges, while higher layer may identify the concept relevant to a human, such as digits or letter or face. One more thing, the adjective deep in deep learning comes from the use of multiple layers in the network.
Learning has been going in a long journey, and now I, Đặng Cao Cương, will talk briefly about the development history of it back to the middle of 20th century. To begin with, Warren McCulloch and Walter Bitz are the authors of the first neural networks-based computer. The history of deep learning dates back to 1943 when they first created a computer model based on the neural networks of the human brain. Since then, deep learning has evolved steadily over the years with two significant breaks in its development. The development of the basics of a continuous backpropagation model is credited to Henry J. Cayley in 1960. Stuart Dreyfus came up with a similar version based on the chain rule in 1962. The earliest efforts in developing deep learning algorithms date back to 1965 when Alexei Grigoryevich, Ivan Knenko, and Valentin Grigoryevich-Lappa used models with polynomial activation functions. Convolutional neural networks was first used by Kunihiko Fukushima, who developed an artificial neural network called Neocognition in 1979, which used a multi-layer and hierarchical design.
And then it was a leap when Fortran code were used in a backpropagation in 1970s. In 1985, in Chen and William demonstrated backpropagation in a neural network using fortran code. John Lurkin explained the first practical demonstration of backpropagation at Bell Lab in 1989 by combining convolutional neural network with backpropagation to read handwritten digits. Moving on, in 1995, Vladimir Vepnik and Dana Cousins developed the supervector machine, which is a system for mapping and recognizing similar data. Long short-term memory or LSTM was developed in 1997 by Jürgen Schmidhuber and Sepp Hochreiter for recurrent neural network. So that is history of deep learning before 2000s. Nowadays, deep learning is applied in many fields and it has a great impact in our daily life. But I want to introduce it in this video because it will take a long time. Coming up next time and is an architecture of deep learning.
With regard to architectures of deep learning, the number of architectures and algorithms that are used in deep learning is wide and varied. Look at the timeline. For 25 years, deep learning has developed many kinds of architecture. Here is a file showing types of architecture of deep learning and their applications. In this section, Nhật Hoàng will talk about two typical types, which are RNN, which stand for recurrent networks, and LSTM, which stand for long-term memories.
RNN is one of the foundational network architectures. A recurrent network might have connections that feed back into prior layers or into the same layer. It allows RNNs to maintain memory or past inputs and model problems in time. RNNs can be unfolded in time and trained with standard backpropagation or by using a variant of backpropagation that is called backpropagation in time, BPTT. The LSTM was created in 1997 by Hochreiter and Schemhopper and unified LSTM in products that you use every day, such as smartphones. The LSTM departed from typical neuron-based neural network architectures and instead introduced the concept of a memory cell. The memory cell can retain its value for a short or a long time as a function of its inputs, which allows the cell to remember what's important and not just its last computing value. The LSTM memory cell contains three gates. First is the input gate. The input gate controls when new information can flow into the memory. The second is the forget gate. The forget gate controls when an existing piece of information is forgotten, allowing the shell to remember new data. Finally, the output gate controls when the information that is contained in the shell is used in the output from the shell. In 2014, a simplification of the LSTM was introduced called the Gated Recurrent Unit, GRU. This model has two gates, getting rid of the output gate present in LSTM model. For many applications, the GRU has performance similar to the LSTM, but being simpler means fewer waste and faster execution. However, the LSTM can be more expressive with more new data, can lead to better results.
Study about the architecture, and now follow me, Nhật Hoàng, and see something interesting things that deep learning can do. Siri, Google Assistant, Alexa, you are definitely familiar with this name. That's right, virtual assistant is one of dozens of applications of deep learning. Virtual assistant is used deep learning to know more about a subject, ranging from your dial now preference to your most visited spot or your favorite song. They learn to understand your comment by evaluating natural human language to execute them. With deep learning applications such as text generation and document summarization, virtual assistant can assist you in creating or sending approximate email copy as well. You want to translate a band in Japanese or Chinese Pakistan? With the Google Translate app, it's now possible to automatically translate photographic image with text into a real-time language of your choice. All you need to do is to hold the camera on top of the object and your phone run a deep learning network to read the image, convert it to text, and translate it to a text in preferred language. Besides the industry, deep learning also has a great impact in healthcare. What I want to mention here is the developmental delay in children. Researchers at the Computer Science and Artificial Intelligence Laboratory at MIT and Massachusetts General Hospital Institute of Health Professions have developed a computer system that can identify language and speech disorders even before the kindergarten, when most of the cases traditionally start coming to life.
Closing note inspired promising, in some cases impressive, results that have been documented in the literature. Significant challenges do remain, especially as far as the theoretical groundwork that would clearly explain the ways to define the optimal selection of model type and structure for a given task, or to profoundly comprehend the reasons for which a specific architecture or algorithm is effective in a given task or not. These are among the most important issues that will continue to attract the interest of the machine learning research community in the years to come. That's it. This is the end of our video. I hope that you enjoy watching the video and you can pick up some information about deep learning. Last but not least, thank you for watching and bye.